Hey all, welcome back. Good to see you again. Thanks for joining me in the channel, and hope you're all well. Today on the bench I have a Pioneer QX-747. This thing's a beast. I had a hard time lifting it up on the bench here. It's so heavy. It's 42 pounds, 44 pounds, something like that. And this is one of Pioneer's quadraphonic receivers. This thing's massive. This is it probably doesn't even fit on my bench properly. This thing's 22 inches wide, and just for comparison, normal stereo is 17 inches. So this thing is massive. Like it's got an extra couple inches on each side. And as you can see, it's fully loaded with all kinds of features and stuff. I picked this up at a garage sale, this and a pair of speakers, for a really decent price, so I snapped them up. No delay whatsoever. I'll take it. And yeah, I'm going to do a full restoration on this. It's going to need a lot of work. The main thing that really annoys me with this receiver right now is it stinks. It's got a lot of bad smells coming out of it, especially you turn it on and it starts to warm up and you get all kinds of new aromas coming out the back, and it's just nasty. But we'll fix that. So I'm going to do things a little different this time. What I did is I hooked this up on the desk and I listened to it for about 2 weeks just to get a really good baseline understanding of what's wrong with this thing. And this thing is just loaded with problems, so much so I made a list. So let's go through this list of what's going on here. The volume knob is bent. I don't know if you can see this. It makes an awful noise too. But the shaft is all bent. And then on closer inspection, quite a few of these are bent. This knob is bent. That one's bent. I don't know if you can see that on the camera. They're just not straight. That one's fairly straight. That one's good. I think that one's bent and that one's bent. So I got some bent knobs on here. I'm going to have to straighten them out and be careful without snapping off the shaft. This one, for example, it's got a really wicked hook to it. So yeah, the volume knob is scratchy. And you can hear that. I don't know what the hell's going on in there, but it's definitely not good. And all the potentiometers on here are dirty. You know, the tone controls aren't too bad, but the volume pot is really bad. The balance controls are. We'll get to that though. I got lamps out, so let's try this. I don't know if you can see this. Turn it on, and pretty much half the scale's burned out. The indicator lamps up top are working. They're all working, all those indicators, and then the meter lamp is working. I got a couple behind the scale that are out, and I got one that's out in the scope, the output display. I got one lamp that's burnt out, and I got 3 lamps that are so dim that I can barely see them. I have a feeling that they are very, very old lamps, and the inside of the glass is all smoky and dirty. So we'll get to that. Yeah, like I said, dirty pots. These balance pots, there's 4 balance pots, one for each channel, and these are the worst. Some of these I think are totally damaged to the point where I might have to replace them, because there's complete areas of the wiper that doesn't make contact, and the channels just totally drop out. Now I also have problems with when I'm playing it, one channel will cut out, or both channels will cut out, or one channel will go scratchy and distorted. If you give it a little kick on the volume, give it a little kick of power, it usually comes back, right? Now what that's telling me is the speaker relay is dirty and oxidized. And it's not too bad on the front amplifier, the 2 channels in the front. But I've been using those front channels mostly for the last 2 weeks. And I think I got a lot of the bugs worked out of it just from using it. I think it kind of works its way out. But then when I go back in and I switch my speakers over to the rear and I try it. It's just terrible, absolutely terrible. I got a loudness switch that wants to come on when it feels like it, and then you have to do this a few times to get it to come off. So you'd be listening to music and all of a sudden the bass would start booming really loud. FM distortion, AM FM distortion. I did try it. When I first tried it, I had a lot of distortion on all the AM and all the FM channels all in the audio. And I think there's a problem in the tuner section, the final stages of the tuner section, where I'm getting a distorted audio. And we'll look at that. The FM is weak. It's picking up FM stations, but I'm not getting a strong signal on the meter. So we'll have to look into that as well. The 4-channel decoder, it sets a 2-channel. When you set it to 2-channel, only the front 2 speakers will work. When you set it to 4-channel, it brings in all 4 channels. Now, when I set this to RM, I think can't remember what RM stands for, but when I go to RM or SQ, the audio quality drops off the map and it sounds like garbage. So there's something going on in the CD4 decoder, and I think it probably going to be needing a full recap on that part too, because it just sounds terrible. AM distortion, same as the FM distortion. We got a bad amplifier in the rear. Right rear amplifier is bad, I believe, because when I listen to that amplifier will cut out, and if I kick it like this with the volume, it doesn't come back in. It kind of crackles and pops really loud. I think it's got cold solder joints in it, but I'm not sure. But that's my prediction for right now. Everything else just seems to be a dirty relay contacts, and that's what's causing the sound to cut in and out. When the front 2 amplifiers are working, this thing sounds great. It's got a really clean, powerful sound, and it's got a real nice sound to it. The scope. At first I thought this was dead, but if you look at it, the display is so dim you can barely, even if I cover it up, you still can't see it. But there's 3 lights that are dim and there's one that's burned out. So we have to go in here, we're going to have to fix this display unit. There's a small hum on the phono stage. It's not that bad, but I'm going to do a before and after comparison to see. And that's pretty much it. What else? Speaker relay, mainly. Dirty pots, dirty switches, bent knobs, and the channels cutting in and out. That's the relay, I'm assuming. AM FM distortion, and the 4-channel decoder sounds poor. We've got right rear amplifier, doesn't sound very good. When I listen to the front 2 amplifiers, it sounds great. When I switch it over to the rear 2 amplifiers, it sounds like garbage. So there's something going on with those amplifiers in the back. So we're going to look at that too. First step, I guess, be blow the dust out of this thing. This thing's filthy. So I'll be right back. Okay, let's have a little look at the front and the features. On the bottom here we have our main master volume pot. This is a master volume control for all 4 channels. And then on both sides we have CD4 separation pots, one for the left, one for the right. And this allows you to adjust the matrix separation between the 4 channels, between front and back. And up here, this looked like a little oscilloscope, but it's not. It's actually a 4 band display, one for each channel. And there's a little, let me turn it on, I don't know if you can see it, it's so dim. You see the 3 of them are lit. Get this lights to go out. You can see 3 of them are lit and one of them is burned out. And then you have, these are your balance controls. You have an individual pot for each channel. Front and right for the front, left and right, and left and right for the rear. In the middle here, this is a really awkward thing. I found this is really strange and awkward. It's having this power button in the middle of nowhere. Usually they have it up on one side at the bottom, one side or the other, but here it's in the middle, and they put a little orange dot on it to make it a little more obvious. Otherwise it would probably totally get missed. Headphone jacks, 4-channel headphone jacks for front and rear. So if they did make headphones, quadraphonic headphones that had 2 speaker elements in each cup for each ear, and you would plug those in for your left and right, front and rear. A couple switches here for the level indicator. When both of them are out, when both switches are out, it's the least sensitive. The meter is the least sensitive, and if I click in one of these, I make it 10 dB more sensitive, and if I add another switch in, it'd be 10 plus 20, it would equal 30 dBs. So these are additive, so I can use these independently or together. Indicator lights, got 2-channel, set up for 2-channel operation. When it's in 2-channel, only the front amplifier will be working. The rear amplifier will be disconnected and be silent. And then when you switch it to 4-channel, it will feed the information from the front amplifiers into the back amplifiers as well. And you can run all 4 amplifiers. And CD4, that's the matrix decoding. So here in the middle we got 4 pots. We got a front treble, or bass and treble, and we have a rear bass and treble. So these are independent. Control the front tone controls, and the rear tone controls are completely independent. That's probably because if you're going to use quadraphonic speaker system setup, when you got 4 speakers, you're not going to have 4 identical speakers. You're going to have 2 different pairs, and you want to maybe do some tonal compensation on each pair individually. Got a weird convoluted speaker setup here. The speaker switch is not what you typically see. You know, one for the back, one for the front, or sorry, one system 1 or system 2. We got one switch here for the rear, and you can select either between A set or B set, and there is 2 sets of outputs on the back for your rear speakers. So you could wire in 6 speakers total, but you can only use 4 at a time. So you can select between the A's or the B's for the rear, and for the front, all you have is a switch that turns them all off. And if you're going to be using headphones, you would switch all your speakers off. And then when you want to listen to music, you turn them all on. And there is no way to turn the fronts off independent of the rears. Either they're all off or the rear state goes off and the fronts are on. 2-channel tape loop, a 4-channel tape loop. We got an adapter loop for a Dolby noise reduction system. So you have an external adapter for Dolby noise reduction, a loudness button, and an FM muting. Last few controls, we got our function input selector, auxiliary phono. It's got 1 phono, FM auto, FM mono, and AM. It's pretty basic, pretty basic function there. And then we have our 4-channel switch. This is our mode switch for how we're setting up the amplifier. We have 2-channel stereo, 4-channel quadraphonic. RM is real matrix, I believe, and SQ, I'm not sure what SQ stands for. But these 3 positions are run through the 4-channel decoder and matrix, depending on your program source, if it's going to be FM or phono, depending on where you're getting your quadraphonic source from. If you have a quadraphonic tape deck and you wanted to run a 4-channel tape deck, you would set it to CD4, and you would input all 4 of your tape deck channels into the back. Okay, a little look at the back here for the connections. We got a phono input, stereo phono input, stereo auxiliary input, a 2-channel tape loop for the tape monitor. So we got the monitor here and record, and then for the 4-channel, here's the extended 2 channels for the 4-channel tape monitor loop. And this is for the noise reduction adapter. The Dolby noise reduction adapter is in and out. We've got 2 channels there. We've got a 4-channel multiplex output. This comes from the FM tuner. de-emphasis switch, 50 microseconds or 75 microseconds, and it's locked in at 75 right now. Here's the extension of the 4-channel tape loop. So we got channel 1, channel 2, no, sorry, channel 1, channel 2, channel 3, channel 4. And the same with the adapter. So it's a 4-channel adapter. And then we got speaker connections. These are our front 2 speakers, left and right. And then we have 2 sets of connections, A and B, for the rear speakers. Got a bar antenna for the AM. And this switch here, I'll have to open it up to show you. It's tight. It's got a thumb screw on it. You can loosen it off, and when you open this door, you hear a switch being deactivated. Now, there's a plug here. What this does is this sets up the amplifier for 4-channel operation or 2-channel operation, depending on how this is placed. If I put it in like this for 2-channel, you can see 2-channel in the little window. What that does is it sets up the power transformer to provide extra, let's say, kick or output for the 2 amplifiers in the front. For the front, the 2 rear amplifiers are deactivated, and you get actually a power boost out of it. And if you want to run it with all 4 channels, you put the connector that way, and it sets up the power transformer for running all 4 amplifiers with a lesser amount of power, so it doesn't overload. Inputs for the tuner: we have a switchable voltage mains power selector. Right now it's set for 120 volts, and then we got 3 courtesy outlets. I think 2 of them are, one of them is switched. One's switched and 2 aren't. So just by peeking through the vents here, it looks like we're really caked with the dust. So I brought it outside. I'm going to give it a blow job. Took the screws out. Let's have a look. Wood looks good. Look at the filth in here. Let's get the compressor going and see what we can do for this. Okay, here we go. Looks like we got it for the most part. I think it's looking a little better. Depending on what this thing needs, it might be pulling boards out to change capacitors. It might look like might be doing that. So let's have a peek inside. Nice construction. That's the one thing about these pioneers from this era, is they really knew how to build them. Look at the rat's nest of wiring going on down in here. Here's our scope via our faux scope indicators. Quite a big, massive power transformer. We got 10,000 microfarad caps. Audio amplifier block. This looks like it might be a phono stage. I don't see the quadraphonic decoder. I think it's underneath. But Well, this is good. At least I got the top cleaned out, and we can pull the bottom off and have a look inside later. Just wanted to get this done before I bring it in the house. Make sure there's no critters coming out, and keep the dust down to a minimum inside the house. This thing is so massive I can't even get it in frame. So let's pull the lid off and have a look. It's got a nice, a nice plywood lid and sides. It's all covered with veneer. It's actually not too bad a shape. The wood finish. It's got some gouge. There's a scratch there. There's a few little scratches and stuff. Not too bad, but it's a lot better than most I've seen. So we're in. It's quite a beast. Got a tuner block here. It's all shielded and covered. Big massive power transformer the size of my hand. And we have two 10,000 microfarad caps. It's very nice to see capacitors sized properly. Our speaker relay, you can't really see it back there, but that's where it is. Down here we have our meter, our output meter. And you see the lights on from the back here. I don't know if you can see that. But yeah, there's little incandescent lamps in there. I think one of them's burned out and the other ones are dim. Back here we got our 4-channel power amplifier. We got a board on this side and a board on this side. I think this is probably going to be getting a full recap as well. Little board here, I think it might be the phono equalization. I'm not sure. Could be something to do with the 4-channel, but it only looks like I have 2 channels here. So I think this is the phono equalization. Underneath it I think there's a matrix board for the quad. So the bottom is quite dusty. You can see that. And all the screws are loose. I think somebody's been in the bottom before. There's some kind of a potentiometer adjustment here, accessible by the bottom. And it is some kind of a potentiometer. I'm not sure what it does. It's not really marked in any way. So let's take the bottom off. You see the dust and filth in this thing. I did blow it out, but I did not blow out the bottom portion of it. So we'll have to continue cleaning. Quite a bit going on here. There's a lot of stuff jammed in the bottom here. A lot of electronics. Power transformer. We have a power supply board here. You got 4 fuses, it looks like, and regulators mounted on a heat sink. The bottom of our power amplifiers, and this looks like the matrix board, the 4-channel matrix board. Tone boards, there's 2 tone boards here and another decoder board here. I'm not really too sure of how they do this. We should go look at the block diagrams, but a lot of stuff going on here. It's all wire wrapped. All these posts are wire wrapped. Some of them are soldered, but most of them are wire wrapped, so that'll be okay. So I guess what I'm going to do is I'll take the front panel off and then we'll get into it. I think what I'm going to do first is I'll break this down. Since it's going to be quite a long, extensive repair, there's a lot going on here. I think I'm going to break this down into a few parts. I got the part 1 here where I kind of did the intro and went through all the problems I'm experiencing with it, and then maybe we'll finish off this part by going through the power supply, and we'll see how this is holding out. And then one of the other parts, maybe we'll do the relamping and maybe the capacitor change. I'm not sure, but we'll see what we can do here for this thing. My plan is for it to give it full restoration, clean it up totally, get it working 100% again, and then find it a new home, hopefully for somebody. I don't think I want to keep this thing around. It's too big. All right, I think the first thing I'm going to do for this receiver is attack the speaker relay. This seems to be the source of the biggest problems this receiver has. Channels cutting out. You can get a channel that cuts out, and then when you bump the volume knob, give it a kick of power, it comes back on. That's typically what's going on in the contacts on the relay are dirty. And when you give it that shot of power, it usually sends through enough voltage and current to just kind of clean that contact for a minute and bring that channel back. That seems to be the biggest culprit what's going on with this thing. So what I'm going to do is I got two options. I could replace the relay or I could clean the relay. But I think what we're going to do is we're going to, instead of replacing it right off the bat, because I kind of looked, I gave it a half-assed look, effort in looking at replacing this, and yeah, there's lots of options, but there's no direct drop-in replacement. This is kind of a unique relay. It's got on the cover, this transparent cover, they have a couple of mounting ears, one here, 2 screws. You could take that relay out, but there's really no need to take these 2 screws out. All you need to do is release the sides. The sides are holding what the relay in, so if you can just get a screwdriver in there and flex the sides out, the relay will pop out of its cover, right? So what I'm going to do is I'm going to try and massage this thing out if we have enough give in the harness. We can massage this relay out and then we have full access. Okay, so right now I can see that the contacts are all oxidized and they're black. Wish I could get a zoom in on that for you, but you just have to take my word for it. Okay, I'm looking for I'm just going to have a look at this. Yeah, all of these contacts are silver and they all are oxidized. So what I'm going to do is clean this. And cleaning it's fairly easy. We got full access here. I just need to get some paper. So I'm going to get a strip of paper. This is about 1/2 inch wide, maybe 3/4. What I want is a strip of paper that's about 1/4 inch wide in here. So I take double that and I fold it in half. You fold this in half. Keep it kind of straight. And that gives us double thickness. You could use single thickness paper, I guess, but I think the double thickness holds the contact cleaner a little better. So what we're going to do is we're going to fish this. Right now the relay's not energized and the receiver's off. It's not plugged in, and the contacts are relaxed to their normal state, and they're on the bottom here. But when the relay is energized, the contacts that close are the ones you want to clean. What I like to do is get the paper positioned between the contacts that we're going to clean. If it'll cooperate. Let's try from this side. Okay, there we go. If I can get this to cooperate. Okay. So we want to soak this paper. Then we want to close the contacts with our finger and drag the paper through. You kind of want to keep it centered under the contact so that I don't know if you can see that, but there's a dark line on that paper now. That's the dirt that it wiped off. You can do this a couple times. Or you could just rub it back and forth. Okay. One thing I want to do is I just want to have a look at the contacts. So what I'm going to do is I'm going to remove this spring. And what that's going to do is it's going to release the armature. And then I can see the contacts themselves. And I can inspect them. And there's a little bit of pitting on these contacts. Just a very tiny amount. I don't want to use anything abrasive on these. Even though they're probably solid silver or a silver alloy contact that you could file down or sand down to expose fresh metal. Sometimes they might be plated. If they're plated with a gold or anything like that, if you use anything abrasive, what you're actually doing is going to remove that gold, and that's not what you want. So I would just leave these as they are. See, these ones look gold plated, but it's probably just a tarnish because they're kind of a yellow, silvery yellow, but they're also tarnished. So gold doesn't tarnish. So I'm just going to leave this. Actually, what I'm going to do is I'm going to do another cleaning, one more cleaning, and then I'll put it all back together. Now, if you're really suspicious of the relay itself and weren't sure, you could get an ohm meter here and check across these contacts when it's closed. It should be in the low milliohms, and if you get contacts that are giving you a high resistance reading, that's probably your problem. So I'm finished cleaning this, put it all back together, assembled the spring. I'm just checking its function, everything works. So now we just slop it back into its resting place, into the cover, and push it in, and it should snap back in. Now, if you really had to change this, you could do that. All the wires are here. You probably have enough wires, lengthen the wires that you could just snip these off with a pair of cutters and then reattach the wires to your new relay. And if you're going to do that, make sure you take a picture, digital picture of your wiring colors. And it's actually a good idea to do that regardless, because once you remove this relay and you start flexing it, these wires can break off. I'm not saying they will, but they could if you flex it enough. And then you're left with where did that wire come from, or where did this wire go? So you got green, yellow, white, orange, and your red, and red with stripe is your coil. And then you have on the bottom you have another green, yellow, white with black stripe, orange with white stripe down here. That's your color codes. So that's done, job one. Okay, the power supply board here. It's actually mounted upside down when it's in the normal position. So there is a heatsink here with 2 transistors. These are series pass transistors for regulating the voltage. All the heat that's generated by these is going to flow that way, but it can't because it's the board, right? So the heat's going to flow across the board, and it's going to cook all these capacitors. We're going to have a good look at these capacitors to see which ones are bad. You know, I'm probably going to end up replacing them all, but I'm really curious as to how many bad ones we have. So we got to pull this board out, and that might pose a challenge because we got wires on this side and this side. And if we can pull it out enough just to be able to flip it down, then we can recap it and check the solders on the back side. So let's try this right now. I'm going to get a pair of needle nose, and I'm going to... It's sitting on these nylon posts that have a little locking, so you just got to squeeze them together and the post should release the board. Don't want to force it because these boards are brittle. Oh, that one wasn't even locked in. Okay, so let's do this top one. If I can pull on the wires, maybe I can't get my finger in there. There we go. And then we have one here hidden in the corner. Which way is it turned? Okay. Squeeze this, it should come out. There we go. Okay. So hopefully we have lots of, oh, we do have lots. Okay. Another thing, take digital pictures, because flexing this around, these wires will break off. I have a feeling some of these aren't, well, these aren't stranded wires, they're solid core wires. So they will break if you look at them the wrong way. So what I'll do is I'll get a camera and try and take some pictures here. Another thing to check is these fuses, make sure they're all the correct values, because people will jam anything in there at the moment to get it to work again. So we got, what was this one? This is a 1 amp, 3 amp, 1 amp, 1 amp. So let's check these. And like everything else, it's filthy in here. That's a 1 amp. And they're all intact. I expect them what they would be because the receiver was working. Three amps. So I clean these better. I like my glass fuses to be clean so that the next guy that comes around doesn't have to squint and peer through that fog. Last one is a 1 amp. That's what we got. All right, so let's get this board rolled over somehow. Whatever is the easiest way, at least. There we go. I don't know if you can see this, but some of the shrink wrapping on these electrolytics has shrunk more than originally put on. When you see the shrink wrapping going back like that, it's usually because they've been exposed to heat. So what I'll do is I'll just ESR some of these caps. What do we got here? 220 UF, 220 UF, these two. 220, let's see what we got here. 0.5. What voltage rating is this? 16 volts. Should be 0.3. We got 0.5. 0.5. And this one we have nothing. That cap is open. It's open. This cap here, open. This cap here, 0.2. And that should be 0.15. So it's barely hanging in there. Another cap here, 1.4. I can't read the value of it because it's turned the wrong way. A 100. So it should be half that value. Let's see what these three on the bottom say. I think they're wired in parallel. Two of these are wired in parallel. 0.16. 63 volts at 100. Yeah, it should be half that. These caps are all tired. What's this one? 1000 microfarad. Measures okay. So what I'm going to do is I'm going to replace these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 caps on the power board. So I think they are done. So I just flipped the receiver over so it's easier to access the bottom of the board here. It just kind of hangs by its own weight. But I am pulling out capacitors that are perfectly good, and I'm replacing them. The reason these are perfectly good is because these are quality capacitors. These are Nippon Chemcon. These are oversized, I believe, for the application. It's a 220 microfarad capacitor at 50 volts, but look at the size of this can. It's huge. So it's got more internal, let's say, build to it. Like it's got more plates, more of the wrapped up core. And also I'm finding another thing that Pioneer did to probably help reliability and quality is a lot of these capacitors are doubled up. They're in parallel with each other. So yeah, if you have one capacitor that fails, you still have another one that's in circuit and doing the job. So hats off to Pioneer for doing that. But these are all going to get replaced anyways because there are some bad ones in here, even though I'm pulling out some of the good ones. Here's one I just pulled out. It is a 220 microfarad at 16 volts and measures out at 35 picofarads. Sorry, you can't see that. 35 picofarads and then 9 megohms. 5 megohms ESR. Here I got another one. 16 volts, 100 microfarad capacitor. Measures out at 4 picofarads. 3 megohms ESR. Totally open circuit. This is typically what I'm finding in this power supply. Pulling out a few of these and they're totally open circuit. Surprised the amplifier or the receiver even worked. Okay, so what I'm doing now is since I got the power supply board out, I got full access to the volume pot. I wanted to investigate what's going on with that. But one thing I want to do first is straighten these shafts. These shafts are bent. There was a number of them. There's like 4 of them that were bent. And I have a feeling that the knobs were resting on something solid and somebody piled weight on top of the receiver. Either that or it was laying down on the ground and maybe somebody dropped something on the knob, but I'm not sure. Anyways, what I got here, my method of straightening these aluminum pot shafts is get a 6mm deep socket, and it just nicely fits over the end of the shaft, and then you can carefully nudge it one way or another depending on which way it needs to go. And then you'll need to get a small screwdriver in here to spread the split open again. If this is collapsed, the knob won't stay on. It'll be loose, so you have to spread this out again to get the knob to have some grip. And then have a knob here just to try it and just spin it and view it from this angle, and you can see right away if it's bent or not. This one's straight now. And I'll go through and I'll do all these. This one's here is a little bit bent. I'm going to go through and straighten that one next. Okay, so here I got the volume pot out, and I'm starting to understand why it's making that awful noise. You can hear it. Now, I don't know if you can see this on the camera. It's going to be difficult to see, but if you look inside these 4 windows, you can see the wiper. And on this last one, it's all mangled. So I got 3 good wipers, 1 mangled one, and I happen to think this potentiometer here is for the right rear channel. Maybe that's why I had such a hard time getting an audio signal through the back right channel of this amp. It's totally messed up. Now I got one of 2 options. I can take this all apart and try and repair it and see if I can bend that back into some kind of resemblance of a wiper contact arm, or I can look for a replacement. This is a 500K pot times 4, and it's got the taps on it for the volume the volume taps. So I could do that. I can go have a look and see if I can find something. All right, so I went, did a little bit of searching for about an hour. I was looking for a 4-gang pot. Bad news, there's no such thing in existence to buy brand new. It would probably be a special order, custom made job, and we're looking at several $100s to get one. I also looked at stepped attenuators and didn't see anything. Everything was a stereo, nothing that was quad. I could go a stepped attenuator way, but I'd have to figure out a way to gang up 2 of them together, and I don't think that would work. Another thing I was thinking of is getting electronic attenuator chips and maybe building a circuit to control, instead of 2 channels, 4 channels. That would probably be the smartest thing to do. But just off the top of my head, I didn't see any chips that popped out at me that would do the job and be easy to work with. There was some chips there, but it was all microprocessor controlled. And I'm not going that deep into this thing. I'm not going to go crazy with something like that. So my last option is just to take this potentiometer out and take it apart and see if I can repair what's going on in there. Hopefully it's not damaged too bad that I can maybe straighten it out and get it to work again, or maybe I could scavenge parts off another potentiometer that's same kind of manufacturer, same build style. We'll see how that goes. I don't know what's going on here. I don't know why the last one would be buggered up. Somebody was, you know, with their spray cleaning straw, they were stuck in the hole, and then they started cranking the knob, and then maybe it bent the wiper. But it's really mangled up inside there. What I did is I stepped away from the bench for about 4 or 5 days to do, you know, life things, and I left this sitting like this, unattended, and came back in, and the whole room stinks with this thing. Like, it's just it's, the nicotine is just terrible. But we're gonna get through this. We're gonna clean it up. I don't think we're gonna clean the individual boards, but we're gonna clean it up so that it doesn't have such a bad smell. So anyways, this has been bugging me while I was away. I was thinking about this. There's a plate on here that's held on with a couple of tangs, and I think if I just open this up, let's try this right here and right now and see what I can get on this last potentiometer that seems to be damaged from the inside. And yeah, I think somebody got carried away with the straw, the straw in the cleaner. Oh, look at this. This piece is it broken? It doesn't look broken. Somebody tried fixing it. There's a burn here. It's cracked. Mind frame. I hope so. I always got off frame, and then you guys can't see what I'm looking at. It's cracked here on the bottom, and there's a burn here. It looks like from a soldering iron. Somebody maybe tried heat welding it back together. And look at the mess of these contacts. Oh my goodness. They are bent out of shape. Something fierce. Bend those back. So I don't know what the solution is for this. Let's see. Let me see if I can reassemble this and get it to... I think I'm missing a part, to tell you the truth, or maybe not. Let's see here. Put this back. Yeah, it needs a cleaning too. This is all dirty. Everything will be cleaned and lubricated when I put it back together. But I just want to see if I can get this to go back together and resemble. Yeah, it needs spring tension on there. And I think what I can do, I have an idea here. I think what I can do, let me zoom in a bit so you can see as well. I hope that's in focus. I hope I got good light on this. Let me turn this a bit. The aluminum shaft comes all the way through, and it has a little, what I'm thinking of doing is maybe there's enough of that shaft, maybe I could thread that shaft. I don't know if I have a tap that small, or actually I need the die, not the tap. I don't have one that small, but it would be like an M3 thread on there. And then I could just put this piece back on, a washer and a nut, and that would hold it all together. The other solution is I could get a spring on the back of this plate, and that would put pressure on the contacts and hold it all together. It doesn't look like somebody was in here already. You see that, how it's been melted? Here's the other side. This sector opening here is a lot wider than the mating part here. So it's got me wondering, is there a piece missing? Or what's going on here? Okay, let me put my thinking cap on. Now I have a good idea what I'm up against. No, I can't really take that off unless I start. See, the problem is you have to start disassembling from this side and then take off each stage to get to this side to take this cover off. So I'm just going to leave that cover on because it's crimped here. But yeah, it's messed up. Alright, so I mulled this over for a while, and I think the best solution for this is I'm going to take this piece and mount it in here. And part of the problem is this cutout is sectored larger than the piece that's in there, so it's got some slop in the movement. So put that in there like that. But let's see, if I hold that in there and I turn the knob, it's got some play and a little bit of a delay in turning. So I want to lock that so it doesn't have that play in there, that rotational play. So I think the best thing to do is take this piece out, clean the inside bore of that hole, clean the outside of the shaft, apply a little bit of epoxy cement, and then I'm going to reassemble it, and I'm going to position it, and then I'm going to let it set up. Now, before I put the end cap back on this thing, I'm going to find a compression spring that'll fit between the end cap and the rotating arm, and it only needs to be like maybe 2 or 3 millimeters, and it doesn't need to have much pressure either. I just want to make sure that if that epoxy lets go, that it doesn't fly backwards and lose contact on those contacts. So I just want to have the spring in there as kind of like a backup plan. Yeah, I think that's the way to go, and reassemble this and hope for the best, because this thing here, I do have about three and a half. Let me see here. Let me see if I can measure that. I got a ruler here. I got about 3.5, almost 4 millimeters of that shaft sticking out, and I thought if I could thread that, I could put a nut on there. Thing is, I don't have dies that small. I ordered some, but they won't be here for another 3 weeks. So I don't want to wait around 3 weeks. So what I'm going to do is I'm going to use epoxy adhesive and the spring, and then reassemble it. And well, I'll lubricate and clean I already did clean the tracks, and it was quite dirty. But yeah, and this thing is cracked. It has 2 cracks actually, if you look at it really carefully. I don't know if you can see this in the camera. There's a crack up here on this side, and then there's a crack down here. And it's partially the way through. It's not all the way through yet. The blessing is this black plastic is riveted onto the steel ring by two spots and holds the two halves together. So even if it does split all the way, I think it will still stay together. And the epoxy on the shaft will hold in the center there, will hold it all together as well. So I think that's my best bet for survival for this thing. I was also mulling over using an electronic attenuator. I haven't found a suitable integrated circuit chip that has even like a mono or stereo attenuator for volume control. If it was a stereo chip, I'd have to get two of them and make it a quad. But if I had a chip that was easy enough to interface to, let's say, a single pot, I could have a single pot and control the chip, and then the chip itself would do the attenuation of the volume signal. And I think that would be great. But I don't know of any chips that are available that are easy to get. They're probably all out of production by now. They'd probably be something from the 80s or 90s. If any of you know of a chip that you could use in that kind of application, let me know in the comments. I'd like to know about it, because you never know, in the future you come across a pot like this, and instead of trying to source a new pot, it'd probably be easier just to build a little attenuator circuit and put a cheap single gang pot in there to give you your control, and the rest is golden. But yeah, let me know if you know anything about that. Okay, so I'm going to mix up some epoxy. Well, first I'm going to clean this really well, and then I'm going to mix up some epoxy, and then I'm going to put it all together and let it set up, and then we'll see how it works. I'll clean the other pots first, these other three, before I do any adhesive. Okay, so I got it clean, glued, and clamped. I'm just going to wait for that to harden. I'm just betting that's going to hold, but I'm not 100% sure. That's why I want to add the spring behind there, just to put a little bit of pressure on the rotor to keep it in place. All right, so here it is a couple hours later. I let this epoxy set up, and you can see it's in there, it's holding, and it seems to be working. No weird noises anymore. It's gliding nice on the carbon track. I bent those fingers so that they land on the carbon track again. Now I was planning on putting a spring in here to put some back tension on that rotor, but I decided against it. I didn't think that was the best idea. What I came up with though is I have a spacer washer, and I did some measuring here with a micrometer. Let's see if we can do this again. And what I'm going to do is use this washer, and it is, let's see here, it's about 67, so it's just wide enough to fit in there. So I'll give it a little bit of lubrication if I can find it. I don't know what happened to my, oh, there it is. Give this a little bit of a dab of synthetic grease just on the back side here, and on the washer itself just put a little bit. Put this washer on, and that should hold it in place if glue ever decides to release. Put a little bit on the end here too, because you get full rotation. Okay, good enough. Put the back plate on. And that is it. Let's crimp this down. And yeah, I treated the carbon track and the contacts with deoxit fader, and it's all good. Okay, so we're done with this. It's all cleaned and all back together. Okay, so what you're looking at is I'm testing the main filter capacitors with my bridge. This one comes up at 10,900 microfarads, which is good. It's got an ESR of 23 milliohms. It's not bad for an old capacitor of this age. Here, check its neighbor, and it's quite a bit lower. It's pretty much 1,000 microfarads down from the other one, and ESR is 26 milliohms. But what I'm going to do is I'm going to replace these two caps. Even though they're still fine, they're probably doing their job. They're not balanced very good. So what I want to do is get a pair of new capacitors in there. I checked, I can get the same size capacitor in a 15,000 microfarad, and they're about 15 bucks each for me anyways. So I'll get a pair of those, put those in, and then we'll be done with the power supply. This part's all done, except I got a little bit of dust here I didn't clean up. This was fully recapped, and let me show you what else I've done here. I fully recapped both tone boards. They have, all the capacitors have been changed. There's one thing I noticed that in this receiver, every time I see these little blue Sanyo capacitors, I don't know if you're familiar with these little things. They have an epoxy end on them, and they have Sanyo, and usually they're low value. This one's a 1 microfarad at 25 volts. And there's other ones here, there's smaller ones. These ones are 0.22. And I see a lot of those in this receiver. Every time I see those capacitors, I start warming up my soldering iron because I know they're garbage. So yeah, they're all coming out, and I'm pulling out a few here too. So like for example, the 1 microfarads are getting replaced with film caps. All the capacitors in the signal path will be replaced with new audio grade, and then I go through and I test any others. For example, this one here is a power supply cap for this board, and it tested down about 40% on value, so I replaced it. These other two, they tested normal and fine, so I left them in place. So that's how I'm going to go with this receiver. I'm going to go through and test everything. Anything that's suspect gets replaced. The blue Sanyo caps will get all replaced regardless of how they test. And pretty much it. That's how I'm going to go with this one. Yeah, there's a lot of capacitors in here, a lot. And then I flip it over, there's more on the other side. And power amplifier. I'm still having troubles. I'm still ciphering how to get this board. This is the bottom of the switchboard here. So there's all these switches here. They need to be cleaned desperately because some of them are really stiff and gummed up. And so I need to get at that. No access from the bottom. And from the top, if I carefully flip this around, you can see it's kind of buried here with the dial lamps. All the dial lamps are in the way, and the dial string, the metering, everything's in the way here. So it's going to be a real pain to get at. I'm going to have to figure out something to get at that because these switches need to be dealt with. Probably there's also capacitors on those boards too that need to be addressed as well. But we'll get it. We'll get it. Let's give it some time. All right, so I think I'm going to put this back together, put these two tone control boards back in, and then I want to do a quick test because I have serviced the volume pot. I serviced the bass and treble pots on both control tone boards, and I replaced all the caps in the power supply. Reworked the relay, cleaned that up. So I want to give it a quick test to see how things are working now that I've done some basic work on this thing to get it back. So we're going to give it a try. Okay, got it hooked up to the rear speakers. Let's try this out. Turn it on. Turn up the volumes for the rear. Left, right. What else do I need here? I need speakers. No, that's not. This is speakers. Okay. Right channel. Left channel. Nothing. Is it the same thing? Yeah, we still got a dirty switch here. And this is the one I haven't cleaned yet. I cleaned this source switch, but not this quadraphonic switch. Things are moving around here as looks like we might have some loose, we've got some loose contacts on this. Yeah, things are moving around, which isn't cool. So we still got signal path problems on the line level, and it has to do with the switch. So I'll go after that next. But all the channels are working because I can go here and touch on the volume pot. That's right, left. So that's working. This volume pot is working, which is what I was worried about because we did that repair. So let me get this cleaned up and see what we can do. Okay, so I think I'm going to wrap it up here today. I don't want to have one video for this thing because I think it would go on for hours. There's so much that needs to be done and so much to go after that I don't think one video would be good for it. You break it up into manageable chunks. So what I've done this week is repaired the volume potentiometer. The right rear channel is on the back here, and I took that apart and fixed that. It is working now. It's working good now. It's clean, no problem. I took out these two tone control boards, one for the front, one for the rear, and I cleaned the pots, recapped these. I recapped the power supply, and we found that there was like three or four open capacitors in this circuit that were, I'm assuming this circuit is voltage regulation for the tuner and the other control boards. Another thing I did is I replaced 4 of these sannule caps, those blue sannule caps, with film capacitors. This is the protection board. Now the protection board is working good. I checked the other ones, they're all fine. I left them alone. Protection circuit's working fine. I cleaned all these potentiometers and this switch, but not this switch. This switch is still giving us headaches on the rear channels. It is not making a connection on one of the channels, so I have to go in and fix that. I think I might have a bad wafer switch here. I don't know. I see wires wobbling around. And we're going to get it after that. Other than that, still got lots to do. We got the tuner to work on, the power amplifier, and these two boards. I think one of these is the phono equalization. The other one I'm not too sure. I think these two boards are for 4-channel processing, the decoder and the 4-channel decoder. This board I'm not too sure what it is, but we'll get to it. So I think that's it for now. And seems like we got and the relay. Yeah, we did a clean on the relay and it's still not behaving. So we might have to go in and clean it again or replace it. So I'll have to look at that too, see what we can do with that. Got 2 new capacitors on order, and I have new balance pots on order. So we'll get that next. Anyways, appreciate it. Thanks for watching, and we'll see you on the next one.